In this tutorial, we will talk about powers of I. An imaginary number is represented with an italics I. It represents the square root of -1. Right here, we should write I equals the square root of -1. If we square the square root of -1, the squared cancels out the root, so I squared is -1. If we look at I cubed is really I squared times I squared being -1 times I. So I cubed is really -I. I to the fourth is really I squared times I squared. So that's -1 times -1. Negative times a negative is a +1. I to the fifth is really I squared times I squared times I. 2, 4, 5. So I squared is -1, I squared is -1, and I. So negative times a negative is a positive, so this is a positive I. So if you look, even powers of I, so I squared I to the fourth, we notice that the I is not in the simplified expression. But if we have odd powers of I, it changes from a positive to a negative, but we still have the I. In letter A, I'm going to start off with adding like terms. I'm going to start off with a -6i to the fourth, because there are no other i's to the fourth, and 5i cubed, 3i cubed, and -10i cubed. So 5 plus 3 is 8 minus 10 is a -2i cubed, and then I have my -8i squared. So what does that really mean? Well, -6, I to the fourth is really I squared times I squared, and I cubed is really I squared times I, and I squared is I squared. Then we can go back and replace all the I squared. So -6 times I squared is -1, I squared is -1, minus 2 times I squared is -1 times I, minus 8 times I squared is -1. And then I can simplify. -6 times -1 times -1 is a -6. -2 times -1 is a +2. And then we still have I. -8 times -1 is a +8. And then again, we can combine like terms. So 8 minus 6 is 2 plus 2i. And that's our simplified expression. In letter B, we're going to go ahead and look at combining like terms, but I to the 8th, I to the 10th, I cubed, and I to the 5th. We don't have any like terms, so let's go ahead and separate out what we do have. So we have 9. I to the 8th is really I squared times I squared times I squared times I squared. So that would be 2, 4, 6, 8. Plus 7, I to the 10th is I squared times I squared times I squared times I squared times I squared. 2, 4, 6, 8, 10. Plus 5 times I squared times I, minus 2 times I squared times I squared times I, because that's 2, 4, 5. And then I'm going to go back and plug in my -1. So 9 times I squared is -1, I squared is -1, I squared is -1, I squared is -1, plus 7 times I squared is -1, -1, -1, -1, -1, because there are 5 I squareds, plus 5 times -1 times I, minus 2 times I squared is -1, I squared is -1, and just I. Then we'll simplify. Negative times a negative is a positive, times a negative is a negative, times a negative is a positive. +1 times 9 is 9. -1 times -1 is positive, times -1 is negative, times -1 is positive, times -1 is negative, times 7 is -7. 5 times -1 is 5i. 2. So we have negative 1 times negative 1 is a positive, times a negative 2 is a negative 2i. And then combine like terms. 9 and negative 7 make 2. Negative 5 and negative 2 make negative 7i. And that's our simplified expression. If we look at the pattern, when I have I to a positive exponent, so I to the 8th, I to the 10th, notice that here there's no I left because I have an even number of I squareds. Then if I look at 8, if I look at how many pairs there are in 8, there's 4. So there's an even number of pairs. That means an even number of negative signs. So that means it's a positive number. Whereas I to the 10th has an odd number of pairs, where we have 5 pairs. So we have an odd number of negative signs, which results in a negative number. So if we keep that in mind, if we look at even powers, we won't have the I. And if we look at how many pairs there are in that power, then we know if we have a positive or a negative. If we have an odd number, then we can look at how many pairs there are. So again, we can look at whether it's positive or negative, and then we will always have an I. So if I have x cubed next to the 5th, notice they each have I. So let's look at letter C. So we start out with a negative 4, and it's an even, so we know there's not going to be an I left. How many pairs are in 32? Well, 16. So we have an even number of pairs. So that means basically all of those pairs multiply together to get a positive 1, because all the negative signs would cancel out. Then we look at 6, I to the 75th. Well, that's odd, so we know that we're going to have an I. How many pairs are there in 75? Well, let's look at 74. There's 37. So an odd number of I squared, so that means I'm going to have a negative. Minus 2, I to the 39th is still going to give me an I because it's odd power. And if I look at 38 and 19 doubled, so 19 pairs make 38. 19 is an odd number, so I'm going to have a negative. Plus 12 times t to the 23rd. Again, that's an odd power, so I'm going to have an I. 22 divided by 2, because I have pairs, I will have 11 pairs. 11 pairs is odd, so I'll have a negative. And plus 89. Now I can go ahead and do the math. Negative 4 times 1 is negative 4. 6 times negative 1 is negative 6, and I have an I. Negative 2 times negative 1 is a positive 2i. 12 times negative 1 is a negative 12i, plus 89. And then I'm going to combine the real values, so negative 4 and 89 is 85. Negative 6 and 2 makes negative 4, minus 12 is negative 16i. So simplified, 85 minus 16i.